Hey guys, welcome back. In this particular video, we're going to be taking a look at how to run RIPv2 version 2 on an ASA firewall. On an ASA firewall. The objective of the video is to actually show you how the protocol works on an ASA firewall. You should have your basic foundational knowledge about how to run RIP on a router in place. My objective over here is to show you how to run it on the ASA firewall. So with that in mind, let's get started. Let's see what are the different things that we'll be covering. Configuring RIP, again, basic RIP commands, the configuration commands for RIP, authentication. Over here, excuse me, we'll take a look at how to configure RIP on the router and how does it differ on an ASA firewall. This is authenticating between two RIP routers talking to each other, verification commands, and we'll actually implement it in a lab configuration setup. So with that in mind, let's get started with RIP version 2. Just like on a router, you use the router command to enable any of the dynamic routing protocols, including RIP. If you want to run RIP, just like on a router, RIP. The more popular version of RIP, version 2, you need to enable it. By default, it sends and receives version 1. So version 2, I want to run that. Same concept of auto summarization that you have on a router is also over here. By default, it does auto summarization on the class boundary, which can lead to black holing of networks. So it's always better to disable auto summarization. If you want to do summarization, do it manually. Auto summarization does cause issues in your network. So your basic commands for RIP would have been router RIP version 2, no auto summary. Just like on a router, this is the same way that you do it on the ASA firewall. Now, once you've done that, you need to now enable the interfaces for RIP. And how do I do that? The network command. Just like you do on the router, on the ASA firewall, the purpose of the network command is to enable the router to send and receive RIP updates. Do you guys remember to traffic? Only traffic for enabled services on the interface is allowed. So when you say the network statement or you configure the network statement, you're basically specifying that on that particular interface that belongs to the network 10, I'm enabling RIP, the service or the protocol. So by enabling it, I'm allowing RIP updates to come into that interface because that's to traffic, basically to 224.0.0.9, which is the multicast address for RIP. All right, same concepts that you have on a router, ASA follows the same pattern. So if you take a look at this configuration over here, this is exactly the way you would have done it on a router. No different whatsoever on the ASA firewall. Again, just like the router ASA firewall, the network statement over here is also based on major networks. So 10, even if I had, for example, in my case, I have 10.11.11.0/24, I cannot say 10.11.11.0. I need to enable it on the major network 10. That means all subnets of 10, it will be enabled by default. This is a major network, 192.168.4.0, so I'm enabling it on that as well. Those are the basic configuration commands for RIP, and as you guys can see, it's exactly the same that you have on a router and in the ASA firewall. They're identical to each other. Now the differences come in when you start enabling authentication for RIP. How do I go about doing it? Authentication, first of all, what is it used for? Authentication between two routers running a routing protocol is to validate that I'm talking to a trusted source. So for example, if I have router 1 over here and I have the ASA firewall over here, when router 1 sends me the updates, I want to make sure it's coming from a trusted source. I can authenticate it. The authentication requires a key, ID, a number, let's say 1, and a key string. The key ID and the key string need to match. Key string is like a password. They need to match between the two devices. If they match, then and only then do I trust the update coming from my neighbor. All right. Authentication can be done in two different ways. You can do it based on clear text, which is the default. Not recommended because in this, the password is sent, the key is sent in clear. So if my key was Cisco 123 and I was running a sniffer, you could actually see the key. The preferred mechanism is MD5. You will need to enable that. In the MD5 mechanism, the key is sent, but it's hashed. So the person in the middle does not know what the key is. So it's a hash version of the key. Much better, much more secure to set it up based on MD5 authentication. All right, clear authentication, clear text authentication sends the password with the update. So the password can be seen if somebody runs a sniffer on the network. Not a recommended way of doing it. MD5 is a better way of doing it. Authentication is enabled on a per interface basis. What do I mean by that? Let me explain that. Let's say I had a device, let's say the ASA firewall. Let's just take our diagram, our network that we're going to be using as an example. So over here, I want to do authentication on my outside network, for example. This guy over here. I have the ability to turn on authentication on a per interface basis. Even if I wanted to turn it on all of them, I would still need to go to each and every interface and individually enable the authentication. So you cannot enable authentication for the entire firewall. It has to be done on a per interface basis. And we'll take a look at the configuration commands as well. But again, with that also gives you the granularity in the sense that you have the ability to pick different keys for over here between 2 and a different key over here, maybe a different method with the third device. So you have the ability to use different authentication mechanisms to communicate to different routers, or different keys to communicate to different routers. Or for that matter, you could also say, I want to do text with one device, MD5 with the other device. So that's also possible over here. That's what I meant on a per interface basis. Now the actual configuration of it. Now this is where there's a difference in the way configuration is done on a router versus an ASA firewall. On a router, you create what is known as a keychain. Keychain is a key holder that holds the key ID. Let's call it ABC, just give it a name. And inside the key, you have two components, the key ID, which is like a number, let's say 1, and the key string, which is the actual password. You take the keychain ABC and which is locally significant, and apply it to your interface, and saying that I want to use this keychain called ABC on my interface to apply the key ID and the key string to the interface. All right. In terms of the ASA firewall, you don't have a keychain concept. So the two components that are exchanged between the two devices are the key and the key string. These two components, rather than creating a keychain and applying it, you apply those two components, which is the key and the key ID, directly to the interface. So in the ASA, the key ID and the key string is applied directly to the interface rather than creating a keychain and applying it to the interface. In addition to the key, you also need to specify what mode that you want to set up. As I said, there's two different modes, text or MD5. If you don't specify a mode, the default is clear text. As soon as you apply a keychain or a key to the interface, the automatic authentication mode is set to clear text. All right. So what are the configuration example, the command examples? Let's take a look at them as well over here. On the router, I've created a keychain called ABC. ABC has two components, which are the key ID, which is 1, and the password or the key string called Cisco 123. I go under the interface and I say IP RIP authentication keychain ABC. So I'm applying this keychain to the interface, which applies the key ID of 1 and a key string of Cisco 123. It's applied to my interface. Besides that, I need to specify my mode. If I want to change it to MD5, I need to put the command in. If I want to leave it at the default, I don't need to put this command in. If I don't put this command in, it will default to text. So as soon as I apply the keychain to the interface in terms of a router, it is authenticating now. It's authenticating based on this key ID and this key string. And because I did not specify the mode, it would use text. But if I want to use MD5, which is the preferred way of doing it, I would go ahead and put IP RIP authentication mode MD5. Now, in terms of the ASA, as you guys can see, I don't have a keychain concept, but I do have the two components, which are the key ID 1 and the key string, which is applied directly to the interface. So the command is rip authentication key, which is the key string, key ID 1, which is applied directly onto the interface. So this one basically does the same thing, whereas this I'm applying it directly to the keychain, to the interface. Now the keychain does give you one advantage. The keychain, although we're not doing it over here, allows you the ability to set a send, accept, and receive lifetime, which allows you the ability to create keys for maybe the next 6 months. So I can say key 1 is valid from the first of this month till the end of the month. Key 2 is valid from first of next month to the end of the next month, and so on and so forth. Whereas over here, I would need to manually go in and change the key every month. Keychain does give you that capability. On the ASA, we don't have that capability. We would need to manually go in and change that. And that's what we're doing over here. All right. RIP authentication mode. We again need to set it up. If you don't set it up, the default is text. Okay. So those are the configuration commands of doing it. We'll actually be doing that in the lab. Once I'm done with it, verification, show run route shows you, actually show run router, not route, shows you the running config for the RIP process. Show route shows you the routing table. Ping verifies the connectivity. All right. So this is something that we've talked about now. Let's go ahead and actually implement it. For the implementation part, I'm going to use the same lab that I did in the static routes. I'm going to get rid of the static routes and implement RIP as a routing protocol all across. That is from router 1 to the ASA firewall, 2 to ASA, 3 to ASA, and 4 to ASA. How do I go about doing it? What are the commands that are required? What are the things that are required? This lab builds on the previous lab, the static route lab. First thing I'm going to do is I'm going to get rid of my routes. There is a command on the ASA firewall called the clear configure command. The clear configure command goes into your running config and takes out that command that you specified. In my case, route was the command that created all my static routes, and I want to get rid of them. So I'll show you a before and after. I'll go to my ASA firewall and I'll do show run route. Show run route shows me all my static route statements. If I want to get rid of all my static route statements in one shot, the command is clear configure and the command route. So as soon as I do that in my running config, I no longer have any route commands. So that means my routing table now will just have directly connected. All my static routes are gone. The reason I did that is because I want to run RIP as a routing protocol, run it in version 2, make sure all 10 XXX networks are reachable from the ASA firewall. So I need to go to my routers and do that as well. Okay, let's go ahead and set up the protocol RIP on all the routers and the ASA and get the routing working, and then we'll go ahead and do the authentication bit of it. So we can say, oh yeah, it's verified, and now let's take a look at the authentication. I always want to do things in a step-by-step manner so you can verify the working of step 1 before we move on to step 2. So let's do the lab configuration. I'll go to router 1 and take a look at all the networks that start with network 10, because that's what they want to do. My password over here is Cisco. Show IP route, and I can do an include connected, shows me all my connected routes. All of them start with 10, so that's good. I'll say router RIP version 2, no auto summary, network 10. That takes care of all my networks because all the networks are subnets of the 10 network. So router 1 is done. Let's go ahead and do it on the ASA firewall now to make sure I can communicate to router 1. Router RIP version 2, no auto summary. You'll notice that I'm doing exactly the same commands that I did on router 1. Network 10, and that's running RIP. So if I go over here and do show route now, RIP or show route router, show route RIP, sorry, shows you all the RIP routes, 10.1, 10.10, 10.20 are learnt. If you do show run router, it'll show you the routing config for RIP. So right now, if you take a look at it, my communication is working properly between what? Router 1 and my ASA firewall. Let's check connectivity to make sure I have full connectivity at this point between ASA and the networks behind router 1. 10.11 is pingable, 10.11.11, which was directly connected actually, or 10.10, 10.1, and 10.20.21. Everything is connected on the inside network. So that's successful. The next thing I want to do is let's do router 3, which is 192.168.3.0. But before we do that, let's go ahead and configure router 3 to make sure RIP is enabled over there. Router RIP, version 2, no auto summary, network is 68.3.0. And I do have, I believe, a 10 network over here. Show IP route includes C connected. Yeah, I do have a network 10. Done. And now I'll go back to the ASA. Router RIP, network. I'll add one more network to my list of networks, which is 3. That would allow me to run RIP with R3. Show route RIP. And there you go. I've learned one route from DMZ3, which is this guy. If I go to router 3 over here, show IP route RIP, I should eventually, give it some time, get all the routes, including the 10 routes. The 10 routes from router 1. So everything is reachable. One thing that I want you guys to make sure that you understand, these updates are not going from R3 to R1. R1 is sending an update to the ASA firewall. That's one leg. The ASA receives the routes, then he creates a brand new update that goes from the ASA to router 3. So these are two different links. They're not a common link that R1 sending the route to 3. R1 sends a route to the ASA firewall, ASA sends it to 3. 3 sends it to the ASA firewall sends it to 3. So there's no low-high type of thing going on. It's two traffic either way. It's two traffic from where to where. It's two traffic from the router to the firewall, router to the firewall, and then the firewall sends the routes. Once it gets the routes, RIP routes, it's going to send it to the other RIP router. Keep in mind, it is not through traffic. It is still considered two traffic. The router communicates to the firewall as the neighbor that it's sending the updates to. Now let's do 4 now. 4 has 10.4 and the 192.168.4.0 network. Let's go to router 4 now, enable that. Show IP route include connected. I have 2 connected routes. Router RIP, version 2, no auto summary. Network 192.168.4.0, and I have a network 10. And on the ASA, I'm just going to add a new network, which is 4.0. So if you do show run router now, you'll notice I've added 2 more networks to my RIP statement. I have 3 and 4 as well. Let's check the route propagation now. Show IP route RIP. Not yet. Give RIP some time. It takes about 30 seconds, up to 30 seconds for you to receive the route. There you go. Received it 3 seconds ago. The 3 seconds over here. I have 10.1, 10.3, 10.10, 10.11, 10.20. Now, the last one is the outside network. Again, outside, I'm just going to enable it on the 10.2 network, not on the 199 or the 200 network. So let's do router 2 first. Get that out of the way because they just wanted to be enabled on the 10 networks. So I have 10.2, I have 192.1.20. I do need to enable that so that I can communicate to the ASA firewall. I will not enable it on the 199 network. So again, router RIP, version 2, no auto summary. Network is 10.0 and 20.0. To support this on the other side, network 192.20.0. So show run router. I have all my networks over here. All my routing would now be in place once the route propagation is complete. Show route RIP. I'm receiving 10.1, 10.3, 10.4, 10.10, 10.20. Let's receive 10.2. There you go. Let's try the pings now. 10.1.1.1. Okay, I can ping it. 2s, ping it. 3, ping it. 4, ping it. I can ping the 10.10.10.1, which is behind router 1, or 10.20.21, which is again behind router 1. So all the communication, all the routes are working. Now this is again not traffic that is going through the firewall. I'm initiating the ping right now from this guy to the router, this guy to here, this guy to here. So it's not through traffic. We'll take a look at through traffic in a later lab coming up, right? So this part is done. Now I need to do authentication. Now let's take a look at where they want to do the authentication, and we'll do it based on that. Configure clear text authentication using a key ID of 1 and a key string of Cisco 123 between ASA and R3. So my clear text authentication is going to take place over here. So R3 needs to have a key. Actually, it will have a keychain. Inside the keychain, I'll create a key based on the requirements. Key ID of 1, key string of Cisco 123. Once I create it, I need to apply it to my E00 interface and specify the mode. I can leave the mode off. The default mode is text. Even if I type the command in, it will disappear. So let's do that on the router and see what's the issue that you'll face if you do that. So I'll go to router 3. I'll say keychain, whatever you want to call it. Keychain is locally significant. Key ID 1, this does get sent across. Key string Cisco 123. Once I create it, I go to the interface. IP RIP authentication, keychain, apply the keychain. By applying the keychain, I'm really applying what? The key and the key string to the interface. Keep one thing in mind. This is something that can really come back to bite you. We have a tendency when you're doing the configuration to put a white space. I did not put a white space, but technically, if I had done this space, it counts as part of the name. So make sure whatever you created the keychain name and the application of the keychain name does not have the extra white space in there. Make sure it's flush. Now I'll also set my mode, but the mode really doesn't help because it is text by default. So mode text is a command. You saw I put the command in. I did it so that I could show you that it disappears. If I go back and do show run interface E0/0, although you do have the keychain command there, mode text, which was the default, does not appear because it's a default command. But at the same time, I do have an issue with the routes now. Clear IP route star. I'll get rid of my routes. Show IP route RIP. The routes are gone. I'll also do a debug IP RIP to see the updates coming in or if there's any problem with the update. Debug IP RIP is a command that shows you the inner workings, the inner packets that are coming into your router in terms of RIP. So let's go ahead and take a look at if it spits out any error in terms of RIP on R3. It should come back in about 30 seconds. So this is my sending. Sending is okay. It's a receiving that will be an issue. See this? RIP ignored an update or pack v2 update from 3.10 because it was invalid authentication. Why is it invalid authentication? Because I have not done the authentication on the ASA firewall yet. So that's what I'm going to do now. And in terms of matching, I'll do an undebug all. So I don't see the messages now. Show run section router. No, yeah, section keychain. I want to show you the keychain. The keychain is key 1 and a key string of Cisco 123. So on the ASA, because there's no keychain concept, what I need to do is I need to go to the interface, which in this case is gig 02 facing R3. Gig 02. In there, I say RIP authentication key Cisco 123. Key is the key string. Key underscore ID 1. Key ID is the key number. RIP authentication mode MD5. Show run interface gig 0/2 Over here, it does put the command in your config, but again, it's still the default, and the key ID is hidden. Now, if I go back to the router and I do the same debug command, let's take a look at what happens. Ooh, still getting an error message. Did I make a mistake? Oh yeah, mode text, not MD5. Sorry about that. There you go, it has disappeared now. I had to do text over here. So let's wait again. Actually, I did get a new update. So all the routes are there now. But I want you guys to see the update now. Let the debug come in the next time around. Sending is okay. This is still sending. Received. Okay, this is what I want you guys to see. Received packet with text authentication, Cisco 123. Do you guys see that? So the password is in the clear. It is not something that's good. Good with that? Now, let's go ahead and do the last thing over here, which is configuring MD5 authentication with using a key ID of 1, key string of Cisco 555 between ASA and R2. So I want to do MD5 authentication between R2 and ASA firewall, which is gig 00 towards R2. So how do I go about doing it? Let's start with the router. Again, on the router, I need to create a keychain, ABC, key 1, key string, Cisco 555. I'll go under my interface, IP RIP authentication, mode is MD5, IP RIP authentication, keychain is ABC. All right. Now, if I do debug IP RIP, again, I'm going to get that invalid authentication message. Let it come up, invalid authentication. So to fix it, I'll do the same thing that I did for R3. I'll go under the interface, which is gig 0/0 facing R2, RIP authentication, key Cisco 555, key ID is 1. RIP authentication mode, I do need to set it up over here because it is not the default as MD5. Now let's check R2. It got that invalid authentication, so let's wait for the next update. The next update will tell you the authentication is happening. It'll tell you it's happening based on MD5. It doesn't tell you what the password is, but it does tell you that is MD5 authentication. And I would have received all the routes. There you go. I can stop my debug. Received packets with MD5 authentication. All the routes are there. Show IP route, RIP. There you go. So that finishes this particular lab up. All the different commands, how you do it on the ASA firewall. This was for your outside interface. That was MD5, Cisco 555, key ID 1. This was for your router 3 on the DMZ, gig 03, Cisco 123, key ID 1, mode is text. I don't need to put this command in, but I'm just putting it so that you guys know that's the command that makes it work. If you don't put it, it'll still be okay, but just for your information. In terms of basic configuration on R1, just the basic RIP configuration, or R2, I did that, plus the keychain configuration for the device. And then I applied it under the interface. All right, then router 3, the same thing. I applied it with keychain again, not required, but I'm doing it just so that you guys can see it. The main thing that's required is this command that applies the keychain to the interface for authentication. Router 4, I didn't do anything extra besides the basic RIP configuration. Our pings were already working. They should still be working. I'll test them out again, and we'll be done with the lab. So I'll go to the ASA firewall, ping 10.1.1.1, 10.10.10.1, 20.20.21. Let's do 10.3.3, 10.2.2, and 10.4.4. So everything is working. Show route rip. It is receiving all the routes: 10.1, 10.2, 10.3, 10.4, 10.10, and 10.20. All right, that was RIP. In the next video, we're going to take a look at how to do EIGRP now, how to configure EIGRP on the ASA firewall. Hope you guys enjoyed it. See you guys in the next video.